Afternoon, everyone. What I'm going to talk is a master student's work. Mr. Parthasarathi, Ramakrishnan, and he's one of my master students from India. He did a brilliant job. I'm presenting on behalf of him. Clearly, the professor has more resources to travel. What I'm going to just say the background is that the student has been attached to the company doing the windows and the doors. It's a relatively large established company. And one of the things we want to present is talk about how we handle the supply chain adaptiveness. Basically, we are facing a lot of changes for every order and how we can adapt it to different kind of configuration for supply chain. I will start slow, and as I said, the general step is briefly introduce the background, and then we have a little literature review. And I think most of us are quite familiar with the concept. And then we try to see what kind of technology we are touching on, and introduce the methodology we adopted, and eventually show the case. Obviously, this is an application presentation, not a theoretical one. But still, I open the floor. Anytime you can interrupt me, we can discuss. See what we can have the chance to introduce each other. Let me just mention what is supply chain in Canada situation. Since this company is a window and a door manufacturer, I did have a negative comment for one of my projects related to this company, submitted to the national board, and they said, what a big deal about the doors and the windows manufacturing. It's not aircraft. It's not something satellite. It's not high-tech stuff. Right? And then you think about it, what is the challenge behind it? So I'm trying to invoke some kind of questions. Maybe you think about it. If half the city is supplied by this company, half of the city. And then if you think about every building, every house would have a customized door and windows. We never tolerate, I want this window and then people give me a much wider window, right? We all design according to our need. And if you think about every house costs, say, $500,000 or even $1 or $2 million in my city, although it's not a high end like Hong Kong, but still costs a lot. How much you will spend on doors and windows? It's a lot. And if you talk about the city, half of the city, they have two competitors, and I work with one of them. And then think about the west part of Canada they supply. There is a lot. So with the size, we are talking about 700 employees, and every week they will have multiple $1 million kind of orders to deliver. And then that is the challenge we have, how we manage the supply chain. And the supply chain including starting with the design of the door and the windows, and material cutting, and then we do the basic fabrication, including glass cutting, including the frame setting. And within 1 week, you have to deliver to the site of construction. So that's what we try to say. So with this, and I would introduce is how we can work from the order, that is starting point, and finish to the construction site. And then what I emphasize is the importance and also the strategy. And then, of course, we try to share the information within the factory, within the partners, and then try to apply the IOT approach. So, IOT to me is more like a one step ahead of extension to the, we call the design integration with the manufacturing. So it's a combination of that, but there are a lot of real-time sensor, real-time data collection, and make use of the network to work out the efficiency. So with that kind of interpretation, I want to say a supply chain is a value chain. And if you interpret that further, it's a technical data flow tree structure. From the say owner of this company, they will provide the data to subcontractors and even to the drivers, right? Think about it. So we have all this kind of data chain, and then we try to automate this, and with real-time automation. I will say real-time data collection, real-time data acquisition. For example, I have an order. The moment, since they have until 1 week window, the moment I receive an order, now think about what is the order descriptions from the site. Assume a salesperson go to your house and then they measure out, oh, you want to renovate these windows. Give the sizes and what kind of choice, aluminum frame or composite frame, and whatever the configuration you have chosen. Then they will put it into an order and use a wireless cell phone or some kind of application directly sent to the company. What company will do? Start the order already. And then the company will think about who will do this. There is supply chain, right? The first thing is who designed it in the first place. They will pull the data from the library and configure it. So what I see is the first step is design. And after design, which is simple and easy to imagine, and then you will look into what to implement, basically manufacture. So we see that there is some kind of multiple steps. After that, you will look into inventory. And the company must deliver within 7 days, but they have to deliver temporarily to the warehouse and sort it out according to order. By the way, I have to say that the supply chain is split into very much detailed subcontractors. For the door manufacturer, they will do windows. For windows, those who are doing the aluminum frame, they want to do the composite frames. And another thing is that glass manufacturing is centralized. Glass is not done by the subcontractor, it's done in-house because glass is automated with a German system, like the good German system. So glass cutting is done in-house by the major company, but the frames are done by the subcontractors. So just to describe the scenario, and then one of the things that we face immediately is that quickly configure the design from order. And quickly split the jobs to the subcontractor of frames and also do the cutting for the glasses. And then, once the glass is done, you must have the frame, otherwise glass fragile and easy to break. So we have that kind of challenge. And with that, we talk about what we can do. And the thing is finding things. In the company, hundreds of orders can currently win, and you don't know which match to which, and which glass fits into which panel, and so on and so forth. It becomes challenging. So the real-time identification of parts and the belongings and the tree structure of the build material becomes critical for the smooth destination chain. And then we see that how we can automate this, implement this. As a master student, he attached the company for only 6 months. He's supposed to develop a program. That's what his challenge they have. And of course, they have to save time. Then, starting with his system review, he realized, hey, IoT has been there for a while, and we are reaching some kind of maturity, and we are able to use some kind of technology like all sorts of things, right? RFID or the barcode and so on. You see the progress. I think this is just from the literature, and the technology is ready over the years, and we are getting there, basically massive use, and the use has been ready for real implementation. So that was basically what I discussed about the thing, and then we start to model the supply chain with a node, with a tree structure. And again, I have to say that node is a dynamic tree structure. It's not an instant. It's not something like in the office I use the tree structure drawing on board. It's supposed to be managed like tree structure in an instant manner. So we use some code to do that. So with that, we also look into what is the adaptiveness to react to the demand. And of course, the company has done a reasonable good job in modularized the configurations. You know, they will have the structure, each of them, how many pieces, and what is the allowed sizes, what is the gaps, and so on and so forth. Those cutting things is as good as they could for the manual work, but we want to automate the information. So what we did is once you receive the order, and then we will based on the configuration, and we want to achieve this. First is coding of the order according to the product configuration. So that tree structure must be automated. And then further we start to look into what is the workers or the subcontractors. I would say if you do this manually, we walk through this kind of distribution of the jobs, you wouldn't feel difficult. You will feel it, okay, follow my basic sense and I can do it. But when you automate it, then that is a bit tricky. Because there's no people monitoring this and we want to achieve it instantly. And that is why we have to have the algorithm to manage the trees, and we have to have the way to manage the selection of the contractor, and then timelines, and also work out the steps. And that is what is conceptually we think about. See, since this is an application paper, I would say you probably can easily think about the real fabrication with automation. The company do have certain kind of automation. For example, cutting the frame is automated. All right, and for example, the glass operation for the cutting automated. So long you give in the coordinates, so long you give the size, the production line can be flexible. And then what happens is that the supply chain, they have some kind of rules. They have some internal system to select subcontractor. What happens to the gap is when you have the order, the design is not automated. It's manual. And then when they have the order coming in, the design has to be manually configured and then move into the network and try to get the subcontractor to receive the configured specs with the size, with the dimensions. And then they will form some kind of working process and we call it schedule and go into the framework of the delivery. And by the end, what they try to do is this: one place, one order, one job to deliver. What does it mean? They don't want to deliver the whole order multiple times. Anyway, the journey is taking some while. So they want to consolidate the data and then eventually deliver with one bundle. Sounds very logical, right? And so what he did is the student really start to look into the multiple structure of the layer and analyze the data. And I know that they have a database for the configuration, they have the database for the order, which is ERP system. And I have to say that currently the ERP system has the order information, has the completion data and specs, but not linked to the design. And therefore, this connection, he has to use some code, we call it generative method, to generate the model automatically and generate the drawing. That is done. And then from there, he will be having the we call the Scantron or some other kind of tools to identify every component and send it into the configuration of the order. Say each window identifies itself, each subcomponent identifies themselves, and where they are and how ready they are. Are they still in the process, or are they completed? Are they in the subcontract A's place, or and eventually what he drives this by a dynamic thing is the glass cutting process. Because glass can't hold it always there. Other sensors can easily put there without worrying too much, right? So that is some kind of thing we talk, and we apply to all these kind of things. The company has all this. Because the subcontractor have multiple choice. Some companies, they are more advanced, they implement the QR code. Some companies just use the manual scan down, use a barcode. All right. So I'm just explain the structure. And then, after identifying the individual parts, we want to say is first location, right? And then we want to look into the delivery schedule. And then we will try to split basically the end consumer, and this is the more like the on-site construction or the on-site renovation required place. And this is the manufacturer set. And then the delivery will be from here to here, following the scheme that is the working system to support this. And of course, sometimes we also have an issue with on-site mayo might not have a network, so we have another copy we call the backup copy. We will switch from online to offline, that kind of thing. I don't know whether you know that once you have the loss of the network, and this continuous process must be backed out to certain state, and then over every place you have to have the copy synchronized, different copies of offline data, and rebuild the dynamic data. So conceptually it's very simple. As I said, when they deliver one truck, typically fully loaded with all the things. And of course, if for a huge building, you can have multiple delivery. But generally, for most of the house, for door and window, one truck will be good enough, one load. And all these can be different kind of contractors, all different stations. And the conceptual thing is very straightforward. But I have to say that raw material has to be cut exactly as what the design come with. The configuration always change, right? So they have to wait for the dimension, then cut instantly. And then every step they use, for example, assemble one window, another assemble the doors, and all are customized, and do the QA check, deliver, and put it into the bundle. So not difficult to imagine. And then we start to look into, as I said, every stage we do have some kind of a backup system. Yeah. 3 minutes. Oh, so far. I didn't realize that, but a little bit faster. Thank you. And then we start to look into the suppliers' nodes and try to follow this, as I said, instant tree structure, look into the process. And then we start to look into the, this is very simple, and then you synthesize the data in the cloud. And I have to say that the cloud is my master copy. All these are the child copies. We do the synchronization. And just an example that they deliver, for example, from one place to another, this kind of route will be based on the order, location, and bundles, and deliver schedule for the construction. It's just an example, run the testing of the code. The structure is simple. The data looks like this. Nobody read the data, just tell you the green one is the order finished, and the yellow one is still have something outstanding. And not so fanciful to look into this, and data driven. And these are the orders, and these are the itemized things coded with the length, weights, and the configuration. A bit boring. I don't want to show you, but just tell you we implemented it. So if we see open flow, quick discussion is that this is dynamic supply chain. To me, we can question about it. And we are managing the tree structures. And we are trying to make it work in a dynamic environment. And they have 27 suppliers, contractors. And as I said, they supply the work for the whole city, half of the city. So every order, almost every order, are customers. I open the floor for this one or two questions.
Are there any questions? So I very much like it to see how this IoT comes also into smaller business and into business where you don't expect them to be. And I think this is very, very good.
So while you are give your question, I could quickly show you some kind of company's information. Go ahead.
Yeah, and actually, yeah, I really liked your presentation. Was really, it was a great application. I mean, apparently this track has lots of applications. So, have you compared it? I think in my imagination, the way where IoT is mostly or most highly implemented in industry is the pharmaceutical industry. Have you compared your ideas with the pharmaceutical companies? Because there is the FDA, they're very strict, and they want the supply chain very, very strict.
I would say depend on company to company, and certain companies want to control to themselves with their own kind of things. For example, I tell you just two competitors in the same city. One competitor used our approach, basically customize everything by themselves. And another company used a big name supplier or service provider, and they use the advanced fanciful ERP system to do all the jobs. You know what? At the end, the other side, the bigger competitor needs to the market because they cannot react to customized requirements timely. But this company working with us, working very well. That's the only thing I can say. Because you do have the quick fix by the developer. We are the developer, in fact. We know exactly how to run the code.
The question is, could you do some reuse from other industries for your code project?
Reuse means that reuse the code for
the ideas, just the ideas. Reuse.
Oh, okay, I got it. I think other than the configuration of the design part, which is specific to Windows industry, the overall philosophy is totally reusable. I have to say that this is applicable to mass customization manufacturing scenario. So long you can use the similar way for decompose the component and subcontracting out, this is workable. Again, this is a case more tailored to this particular manufacturer. It works. We have the liability for that little software. But other than that, we didn't explore to bigger company. But in theoretical part, to my knowledge, should be working. I didn't see any barrier. Yeah.
I'm just curious. Since your company deliver window from Vancouver all the way down to Miami.
No, that is a testing.
Oh, that's a test case. Okay. So, but my question was curious. So, you're working on a company. How willing the company is? Say you develop a system, the data pretty much you access companies' data. How did they
The good thing is this company is totally open to us. I have been working with this company already 6 years, and the company started with only 1 student. Yeah, I think.
So a lot of companies actually are not willing to share the data.
Yeah, I think the trust has to be built gradually, and this company doesn't have any barrier to us. And I have 6 students there. Well, actually, they're taking cheap with my PhD students, and then we still have students going on there. Every year they have 2 or 3 students. We have the regular connection.